These questions are about draw the shear and moment diagrams and show me the maximum shear, maximum moment. Which one of these 5 you would like to solve today?
Can you one be the only of these options?
You do the upper right,
The very top right?
the top right.
We
Top
did that
right,
one.
this one?
We did that one.
Everything else is so easy in class.
We did that in class
Yeah.
Yes.
And in the homework.
and in the homework.
Maybe the one below it.
The one below it,
Yeah, where everything's
the one below it.
all the
Good.
way.
That's only two slices though.
Most of them are about 2 cuts. Because if I put this in question, usually I put P or Q0. When I put this in the test, I put one considering that P equal this amount, Q equal this amount, and one of them usually is 0.
So we could expect 3 cuts at the maximum?
2.
2 or 3 maximum, not more than 3 cuts. So which one? Find out.
What's the hardest one?
This one?
Let's do that one.
The one you're gonna put on the final.
You are talking this. I solved the problems in the class and I put them in the final. The student didn't do well. No worries. So we are talking about this one. This one here. With this here and here. Which one is the simple? This is the simple. And this is the pen. And the whole load is in here. And this one is 1,500 pounds. And 6,000 here. And we have 6 and 4.
Yes.
64. This is given. Find maximum shear, maximum moment, and draw diagrams. Shear and moment diagrams, okay? From this, we send it's easy for you. Keep it like this. Keep this blank. At A, this is A, B, C. A, B, and C. At B, I should have only BY, correct?
Correct.
And here I have AY and AX. Some forces on X equals 0. That means AX equals 0. You see this statement
Yes.
is half point. For this and this. Yes, you can see that it's a 0. You need to show. Okay? So these are you need to pay attention to details and put everything. Sum of the moment at A equals 0. I have 1,500 times 6 times 7. Everybody agrees on the 7. This is rotating this way is negative. 6,000 times 10 is positive, and By, I will write it in here, By times 4 is positive, equals 0. We have one equation, By equal.
750,
How much?
750 pounds.
750 pounds, sum of forces on Y equals 0. We have here 1500 times 6. Hitting down is negative. 6,000 is positive. By is positive. Ay is positive, equals 0. And from here, Ay equal
2,250.
2,250.
250.
AY, let's see, this is 1,500, 9,000 here, negative, 6,000 here, positive,
Minus 750.
is negative 3,000, negative 3,000, BY is
Positive 750.
22, still negative, move it to the other side is positive.
Okay.
Correct. First cut. First cut is here. The forces that I have is AY. AY 2250. Correct? AY. Do we have anything else? AX is 0. And we have 2M at cut 1 and V and the shear. The shear is this way, correct? Down. And this is called V1.
So here, I don't have to label AX, right? Because it's 0 on the
You
cut.
don't need to put it now, it's 0, but you need to show it here that it's 0. Done with this distance here, starting from here, going this way is the X. This is another half point. This is little free diagram. This is half point, this is half point. Sum forces on Y equals 0, V1 equal to 250. Correct? I don't need to write more details. Agree?
Do we have to
Everybody?
write direction for that, or should we just?
My direction here. If you want to go plus 2250, negative V1 equals 0, V1 equal to 250. That means it's down.
Yeah.
Sum of forces, sum of the moment at cut 1 equals 0. I have M1 is positive, correct? And I have 2250 times X. 2250 is going to be this way is negative, equals 0, or M1 equal to 2250 X.
So can we write it just like how you did where it just says like sum of forces Y equals 0 and then just go right down and say V1 equals 2250?
Yeah.
I mean,
Yes.
we can skip the right and the whole equation out.
Yes. Some simple like that, it's okay.
Okay.
From here, I will put a small table up here to finish this. Small table X equals 0 and X equal 4. V1, M1. V1 is 2250, 2250. There is no X, nothing to deal with it, correct? All the time the same X is not involved, no variables in here. M1. M1 is going to be at 0. 0. And at 4, put 4 here times 5 is going to be 9,000, correct? And let's draw here. V and M. V 2250. Positive. The M starting here is 0, ending here is 9,000. What kind of line?
Straight.
Straight line. And it's positive. Let's go to the other cut. The other cut, which it is going to be right in here, correct? I will take this side. It's easier for me. Agree?
Yes.
We have here 6,000. we have here 1500. What else? We have the moment, M2, and we have V2.
Pointing down,
V2.
or pointing up, the opposite of the other one. That's what I meant to say.
What else? That's it, no?
It should be up.
Oh, it goes up, the shear goes up.
That's a question that's always gets me, is how do you know which direction the shear should go?
It's always,
So what side
it's
is
Right
always the
side,
same.
left is down.
Back side is down.
All the time, if you choose this one, it's up. If you choose that side, it's down. Because you get a beam, this beam, you cut it in here. When you cut it, you separate it. The moments on both sides should be this way. This one is, the shear is this one, the shear is this one.
You're going like that.
Now, you need to choose. I choose this one, the right cut, then I use this one. If I use it there, this left cut, I use it
Just
this
kind
one.
of a little bit, turn around and.
From here, this is x from here to this direction, x, correct?
Yes.
Sum forces on y equals 0. I have 6,000 is positive. Negative 1,500 times x. Agree? Positive V2 equals 0, or from here V2 equal
Third X minus
V2 1500x minus 6,000. Correct?
Yes.
Sum of the moment at cut 2 equals 0. Put your finger at cut 2 right in here to see how is the rotation. I have the 6,000 times x positive. Correct? 1500 times x over 2 is negative. Can you see that?
Yes.
Everybody? Your fingers here, this is 1500 times x is the force. This force is going to be located in here. This is the 1500x, correct? Times this distance, x over 2. X over 2, correct?
Yeah.
Everybody? And I have the M2 negative, correct? And another thing in here, equals 0, or M2 equal M2 6,000 x negative 750 x squared, correct? Little table. X equals 0, x equals 6. And here is V2, M2. For V2, x equals 0, negative 6,000, correct? X equals 6 is 3,000,
9,000 minus 6,000.
correct? X equals 6 is 9,000, minus 6,000 is 3,000, correct? Everybody? Let's look at the moment. If the x is 0, the moment is 0. If it is 6, put 6 here, 6 square here, and 6 here, and give me a number, please. 6, 3, 1, 2, 3 zeros.
What else you got?
Other person? 36 times this, 6 times 6.
I got 9,000.
Yeah, I got 9,000.
Oh, did I add them together? Yeah, I added them together.
9,000. Okay, let's
Yeah.
come back.
9,000.
Let's come back here. We said for x equals 0, here's the 0, guys, not here. Here's the 0. Lots of you do mistakes and they started always from the left side. Now the 0 is there. What is the number for x? For v?
6,000, negative 6,000.
Negative 6,000. I'm here with negative 6,000. And when x is 0 is 6, what is that?
3,000.
How much?
3,000.
3. 3,000 is here somewhere. Positive, correct?
Yes.
And here is a line between them. Let's look at the moment. 0 is here. What's the value? For the 0 is 0, correct? And here is the other way.
9,000.
Positive.
Yeah.
What kind of line?
Parabolic.
Parabolic with?
The high point being where it crosses.
The high point is supposed to be right in here. This is the maximum moment. The maximum moment is here, underneath the intersection. This is here, is the maximum moment. The maximum moment happened in section 2, in segment BC, in this segment, correct? This is where the maximum moment happened, or the intersection of the shear here. The shear crossed the line in this section, correct? That the shear here at this point, if when you look at it here, the shear here is 0, correct? Then I will go back here to the equation of the shear and say here this is equal 0. Or x equals 6,000 over 1,500. Can you see that? Come here and put 4 here, 4 square here, and give me the moment in here.
12,000.
12,000. So here, moment maximum equal 12,000 down foot. Shear maximum, is this a 3,000? So the shear maximum, this is,
The negative 6,000.
yeah, 6,000. This is shear maximum, or maximum shear, equals 6,000. Okay? Now look at your, check your work. I start here with AY 2,250. Starting from the 0, I go up 2,250. Correct? No changes. Then I go up again. What is this? This is 3,000 minus 2,250. This value here in red is
750.
750. Do I have, this is the question, do I have a concentrated force of 750? Yes, I have, Py. Then I go back in here, then I go another drop here, I go back to 6,000. Do I have a force here of 6,000? Yes. Of the moment, I started from here, go back there, no drops. There is no concentrated moments. So started from 0, ending with 0. If there is a concentrated moment here, or here, what I should see? I should see here, correct? Or here. If I have in the middle, then I should have a drop somewhere, correct? Okay. So this is a question of shear and moment diagram. So you expect whether one of those, whether one of your homework, or whether one of the questions I solved on the board, to have a question like this: drop, shear, and moment diagram. Is everybody comfortable with that?
Yeah.
If you don't get an A, then there is a trouble in here. There's a problem. Because this is here. What is the difference now between this equation and this equation, or that equation, or the questions you solved in your homework? Absolutely nothing. Even if I come to this and say, okay, here is a moment here, add a moment, for example. Or cut this force from here and replace it with a moment. What's the difference? Any of them? Is this my cell phone? Because I put it on vibrate, but it's still. I'm in the middle of the class.
You apply it wherever it is.
Okay,
Because it's a bending moment, it's not like in there. Yeah, this is unexpected.
this is about friction. So here, we need to eliminate this because this is not an option. But leave it at this moment, it's not your problem in here. Is there a problem with my daughter? Excuse me, hello. Yes. I'm in the class. Talk quickly. What do you want?
Which one? They're both homework.
There's one with books, talk about
Okay, so here are some questions of friction.
Yeah, let's do the one of the ones.
1, 2, 3, 4, 5. All of them about friction.
Let's do the wedge. Wait a minute, did we do the wedge? We did the wedge.
I did the wedge in the class.
Yeah.
One next to the diving. That's gonna be on the.
Which one?
What about the swinging gate?
The gate we didn't do.
Yeah, but that's homework.
Yeah.
Homework one.
I didn't make it all.
Is this was in your homework?
Yeah.
This one?
Yeah.
Is this was in your homework?
That was homework too.
Here?
Yeah, that's pretty straightforward.
Yeah, do the blocks.
Is this I solved it in
Block.
here?
Yeah.
you did it last week.
Blocks and wedges.
So this is not necessary that you will get one of those. These are examples from previous tests. You shouldn't get the same question. Okay, so you should, what I'm telling you here, you will have a question on friction. And again, the question on friction, something I solved in the board, something you solved in your homework, or something from these here, or something from the sample questions that the book gives you there. Which one do you want me to solve, whether in this here, or from your homework, or
Number 15.
which one do you think should be solved?
What else have we got?
Did we talk about this in here? No?
That was on the homework.
Did you solve it? Everybody was comfortable with it?
No.
I wouldn't mind doing that in class.
I had trouble with it too.
Okay, select a question then. I need to clean here.
15? The homework?
Yeah, 15 was the one with the cabinet or whatever, or first refrigerator.
Casters.
Rotating block.
No, it has a rope.
Yeah, you can
There's
There's
a rope going around. To reach around.
I don't know.
That's the one that,
Yeah, that's the last one.
no, that's not the one that you and I were solving.
It's your
The last one is that one.
Yes.
Right.
Come on, guys. Something from these three, or something from these, or other question?
Yes, please.
Friction question. You select.
Number 15 from the homework.
One of these three.
What's that?
15 from the homework.
Right here. This one. The one with the rope on the crate.
Yeah.
Oh, yeah. That one's.
That's the one that Jesse and I were talking about.
Why didn't you?
This is a block in here, and this has this force E at angle alpha. Dimension here, half meter is high. 0.8 meter here. A, B, C, D.
40 kilograms.
40 kilogram. What is in Newton, please?
392.4.
392.4 Newton. Mu 0.35. Find the largest allowable value of alpha, the corresponding magnitude of P. So let's start with find alpha, find P. Good like this? Then we will look at other options. If alpha is 0, let's imagine that alpha is 0. What you get in here? Alpha is 0, so I'm pushing this way, correct? P. And all I need is to be against the friction in order to move. What friction, what forces I have in here? I have N and I have Fm, which it is the maximum friction that this surface can handle. Sum of forces on Y equals 0. I have N equal 392.4. Agree? In this case, F equal 392.4 times 0.35. Agree? What is this? Give me a number.
$137.9. Oh,
0.34.
yeah, actually, he's
How
right.
much?
137.34.
0.34. Let's do sum of forces on X. Equal 0. V equal 137.34. Agree on this? This is P is 0. Why to do it like this? What do I have in here? What do I have? Because I cannot go P is 1, P is 2, P is 5. It's not going to work like this. So I can work here with this R equal. Whatever its equal value, I don't care, but it is at angle, let's call this here beta, which equal what? What is beta?
Tan inverse of 0.35.
Tangent. Negative 1 of 0.35. What is beta, please?
19.29.
How much?
19.29.
19.29 degrees. Somebody asked me about the triangle force when I was walking in, and this is a good opportunity. I have a force hitting down here of 392.4, correct? I have a force here called R, and R is measured at 19, you said? 19.29. Agree? And I have a force in here. This is R. I have a force in here. P. Alpha is here. Correct? Alpha is here. What's the question is? The largest alpha?
Maximum alpha,
Maximum, yeah, maximum alpha.
and then the magnitude. Optimizing it.
It's not going to work as this one. The smallest alpha is 0 and it's going to be perpendicular. That's, we know about it. We did it earlier. If
You have to You have to use some geometry from this picture over here.
Yeah, so the largest alpha without tip in it.
How can we tell this
So,
is a tip, though?
If
You have
this
to
going
move that
to,
over.
if it's going to be like this, 90 degree,
Yeah, it's gonna
what
pull it.
happened?
It's gonna pull it straight.
It's
You can't
going to
tip it.
pull it, so we don't need to tip,
Yeah.
correct? It's
Yeah.
not going to move
Yeah.
it this way, it's going to pull it in this here. So if we put it in here, correct? The actions.
So this is when it's tipping, right?
When it's
just about to
tipping, there is nothing in here, everything is sitting on this corner, correct? Again, it's not going to help with the sum of forces,
Make your
I did,
intersection.
sum of the moment,
I did some of the moment at B. That's how I worked it.
If you draw your
some
resultant
moment
vector,
at B equals 0, I have P cosine alpha times 0.5. Agree?
No, because it's right at, isn't P intersecting B? So there would, P wouldn't,
0.5.
P,
Moment at.
P cosine alpha is going to be this way, horizontal, right?
but P wouldn't produce a moment at.
He's taking the moment at D.
Oh, no, I took one.
Should be at
oh,
C.
never mind. I thought you were taking it at
What about the
B.
moment at C?
I took it at B when I did it.
Moment at C.
Shouldn't that be the pivot point?
You want moment at C? Sum of the forces, P cosine of alpha times 0.5 and P sine alpha times 0.8. And both of them are positive, correct?
Mhm.
What else we have in here?
you have the negative of the weight. times
Negative
0.4.
392.4 times 0.4.
Wait, but if it's just about to tip, wouldn't the weight go all the way on the C? So wouldn't it cancel out?
Or just from the center of gravity?
No.
Oh, it's from
Still
center of
gonna be
gravity?
center of
No,
gravity.
this is the normal
Oh,
force would
okay.
be at C.
So this is not going to give you anything. One equation
P
with
equals
two
system
unknowns.
That's why I did the moment at B.
What's that?
I did the moment at B when I did it.
Moment at D,
At B.
B.
Because that way P doesn't act on it, and I solved
Sum
for
of the moment at B equals 0. So we have n
right.
times,
P,
or I can consider this r here, correct?
yeah,
R,
do that too, either way.
r cosine beta times 0.8.
28, right.
R sine beta times 0.5. What else?
You got your 392.4 times
392.4
times 0.4, because
times
that's
0.4. Let's look at direction. This one is positive, the cosine beta is going to be negative. This is positive, this is negative.
that's.
Equals 0. Agree?
But wouldn't the 392 doesn't that produce a? Yeah, it's positive. You're right.
392 times 4. From here you get the value of r. Correct? What is r from this equation?
N squared, F squared. Derivative N squared, F squared.
Sine alpha is here.
So for R, we don't have beta.
We do have beta.
So if I know R, I know that I'm going.
I got negative 158.4.
How much?
Negative 158.4. I don't know. Somebody's got
Negative 154, anything else?
I got negative 266.
I got 266.
Me too.
Negative?
Negative 266.
Why is it negative though? Shouldn't it be positive?
I got positive
It's
266.
supposed to be positive.
Yeah, I got a positive 266.
Moment at B. Oh, the last
Yeah, I got
the last four, shouldn't that be positive plus 392.4 times 0.4 because you're taking the moment at B?
Yeah.
No, those,
The moment at B, this is positive
Yeah, so it's plus 266.
at B, and R cosine,
no, those are negative, and you swing them over to the other side of the zero.
Yeah, that's negative, you're right.
put your finger here,
Yeah.
this R cosine of the alpha is going to be negative. R sine of alpha is going to be positive. This is going to be positive. So negative, positive, positive.
Okay.
Yes.
Get me
So-
an answer in here.
Does R have to be at C?
If it is at tipping point, so the box is going to be start moving up, correct?
But if it's not tipping,
So this is the maximum, the point that the box start tipping. So if with this R, at that point the box start tipping, that is the maximum moment. From this we can go back and say this is supposed to be bigger or smaller.
Yeah, it should
So-
still be 266.
Positive.
Positive. Anyone back me up on that?
So if this is 266, P equal the square root of 3924 square, 266 square, negative 2 times 3924 times 266 cosine 1929.
Or you could use the law of sines too.
Agree on that?
Yes.
We don't know all angles at this moment.
That we just saw.
We don't know all angles. What is this P? What is the P?
We could just,
You don't know this alpha yet. What is P? I will call this angle here gamma, and I will start here sine of gamma
Say sine of 90 minus alpha.
equals sine of 1929. Give me a number for P, please. What did you say? No answer?
166.
166.
66? Yes.
166. From here, gamma equal.
So you're using a lot of cosine here?
This is law of cosine. This is law of sine. This one is going to be what? Give me this for gamma. It could be other different way to solve the problem, but all the time there
There's
is.
lots of ways to solve this problem.
What's that?
The way I solved this is totally different.
What is that?
Faster?
I'm saying it is not. There is not 100% only one way to solve the problem. What is this? Sine of gamma. What is gamma?
0.529.
Get the angle out of it.
31.96.
31.9 degrees. If this is 31.9 and this is 19.3, what is this here out of 100? Out of 180. This is 3150,
128.8.
128.8. Look at this. If this is 13.9, what is this here? 31. 58.1.
Yep.
That means
Yep.
alpha is 58.1, correct?
Correct.
What did you got? Other people, what did you get in your homework?
That was,
Those numbers,
yeah.
58.1 and 166.
Okay, so you did it in different ways and you get the
Yeah.
same number.
yeah, I
Doesn't
did,
matter
I did
how
the
you
moment,
approach
I
it.
did summation before.
It doesn't matter how you approach the problem, as long as you go step by step, follow it, you will get the same number. Okay, so is everybody okay about the friction?